Hello everyone, this is Mansa, currently pursuing BTech second year in Vasireddy Venkatadri Institute of Technology. Today I am going to give my seminar on the topic graphs and Dijkstra's algorithm. So let me share a screen. And- So first of all, we will see what is meant by graphs. Graphs are data structures used to represent connections between pairs of elements. These elements are called nodes. They represent real-life objects, persons, or entities. The connections between nodes are called edges. Two nodes are connected if there is an edge between them. Here we will notice that if there are n vertices, we will have n minus 1 edges. Next, applications of graphs. Graphs are directly applicable to real-world scenarios. For example, we could use graphs to model a transportation network where nodes would represent facilities that send or receive products and edges would represent roads or paths that connect them. So we will see what is meant by Dijkstra's algorithm. With Dijkstra's algorithm, you can find the shortest path between nodes in a graph. Particularly, you can find the shortest path from a node called the source node to all the nodes in the graph, producing a shortest path tree. This algorithm is used in GPS devices to find the shortest path between the current location and the destination. It has broad applications in industry, especially in domains that require modeling networks. What is the history of this? This algorithm was created and published by Dijkstra, a brilliant Dutch computer scientist and software engineer. In 1959, he published a three-page article titled A Note on Two Problems in Connection with Graphs, where he explained his new algorithm. In just 20 minutes, he designed one of the most famous algorithms in the history of computer science. What are the basics of this algorithm? It basically starts at the node that you choose. It is called a source node, and it analyzes the graph to find the shortest path between that node and all other nodes in the graph. The algorithm keeps track of the currently known shortest distance from each node to the source node, and it updates these values if it finds a shortest path. Once the algorithm has found the shortest path between the source node and another node, that node is marked as visited and added to the path. The process continues until all the nodes in the graph have been added to the path. This way, we have a path that connects the source node to all other nodes, following the shortest path possible to reach each node. This algorithm finds the shortest path and all other nodes in the graph. This algorithm uses the weights of the edges to find the path that minimizes the total distance between the source node and all other nodes. Here we will see an example for this algorithm. First, we will calculate the shortest path between node C and all other nodes in the graph. So we will give the weights for the edges in the graph, and in this second case, the minimum distance is 0 for node C. Also, for the rest of the nodes, we don't know this distance. They will be marked as infinity, except node C. Current node is C and it is marked as red dot. Now this value will be compared with the minimum distance of B. The least value is 1, that remains the minimum distance of B. In this case, 7 is the least weight. So the value for the node B is marked as 7. And in the next case, the same process is checked for neighbor A. We add 0 plus 1, weight of the edge that connects the node C to A, and gets 1. Again, 1 is compared with the minimum distance of A and mark the lowest value. So the value of the node A is 1. The same is repeated with node D and mark 2 as the lowest value at D. Since all the neighbors of C have checked, so C is marked as visited with a green check mark. Now we will select the new current node such that the node must be unvisited with the lowest minimum distance or the node with the least number and no check mark. Here node A is have least weight than all other vertices and A is unvisited. So node A is the unvisited with minimum distance I marked as current node with red dot. So A is marked as the current node and we indicate it with the red dot. And the process will continue until each vertex of the graph is visited. Now the edges from A to all the nodes is checked and least weights are noted. After completion of all visiting nodes from A, we will mark the A as visited and we will keep the green tick mark. The process is continued until each node of the graph is visited. Thank you for giving me this wonderful opportunity. Thank you so much.